Okay, welcome to lesson 8.4 on angle relationships and how can you use angle relationships to solve problems. Measuring angles. It's useful to work with pairs of angles to understand how pairs of angles relate to each other. Congruent angles are angles that have the same measure. Okay, that's an important, I'm going to use that quite a bit. Congruent angles, they have the same measure. Okay, using a ruler, draw a pair of intersecting lines, and I've done so right here. Label each 1 to 4, so I did 1, 2, 3, 4. Find the measure of angle 1. So this is a protractor right here, and it measures angles. I have one here, a little bit larger, and I'm going to put this over here. Now, this is the vertex of the angle, and this is the elbow of the angle. This is 0. And then, so one side would be here, and then the other side of the protractor would be here. And if the other side were here, then I have a 10-degree angle. If it's here, 20, 30, 40, 50, 60, 70. Have you ever seen that a 90-degree angle makes an L? Well, here is that L for the 90 degrees. And if you want to go beyond 90 degrees, you have 100, 110, 20, 30, 40, 50, 60, 70. And 180 makes a straight line. You see that? 180 makes it from 0 to here is a straight line. That's 180 degrees. Now, if I'm measuring, the reason why you have different pairs of numbers here is if you start with the angle here on the left side, that's 0, and then you would have to look at the inside numbers. 10-degree angle, 20-degree angle, 30, 40, 50, 60, 70, 80, 90, again, is still that. And if you want to go beyond 90, then you have to go all the way down here to 180. So this number is for if you start the angle here, and this number, the inside here, is for if you start on the left-hand side. So with this, and by the way, there's also an important fact here. Take a look at this. 20 plus 60, that's 180. 10 plus 170, that's also 180. 0 plus 180, that's 180. 50 plus 130 is 180. There's a reason for that. Think about why that is. All these pairs add up to 180 degrees. 90 plus 90. Okay, so I have my X here. You need to draw something like that. Now for me, to measure this, this is going to be my 0 right here. Now, actually, I'm going to make this my 0 right here. This is 0, and I'm going to measure the size of this angle right here. So I put this right here. You should have a protractor. Now this is the elbow, and the elbow goes right at the intersection right there. So I put that there and line it up. I line it up here, so 0 is covering that line. I'll move it right here. See, it's 0. There's 0 lines covering that line right there. And I'm going to do that. And there we go. So now I measure here 10, 20, 30, 40, 50, 60 degrees is the measure of this angle right here. So I'm going to call this 60 degrees. So M stands for the measure of angle. That's the symbol for angle 1 is 60 degrees. So I'm going to measure angle 2 now. Now it's going to be, hopefully it's going to be 120 degrees. So to measure angle 2, I need to make this 0. So I'm going to move this like this. I'm going to put this right at the vertex right there. I'm going to cover this right here. And so, since that's 0, I'm now having my eye on the other side. So right there. See, I'm measuring the size of this angle. So that's 0. And then I'm going to see where this line lands. So that's 0 right there. And now this line right here lands on not 60, because 60 was over here. I've gone past 90 degrees, so I'm actually at 120 right there. So measure of angle 2 is 120. And that's what that is. Okay, I'll measure angle 3. Okay, I'm going to do this a little bit faster here. So I'm actually going to use the other side. This is going to be 0 here because I'm going from the left. And I'm going to match this with this line right here. And I'm going to see where this line right here ends up on my protractor. So I'm going to line this up, vertex right there. and line that up to 0, and that goes right up to 60. I know it's 60 because I haven't crossed 90 yet, so that's 60. Okay, great. So this is 60. Great, that's 60. Angle 4, well, hopefully it's 120. So I'll go, I mean, it doesn't really matter how I do this, but I'm just going to go here. I just need to see this size opening. So I'll do it this way, here, and I've covered up the 0. See, I've covered up the 0 there. And I'm looking this, I've gone, and I'm looking where this crosses here. It's crossed the 90, so I have to use the larger number, 120. There's 120. And then let me show you that I could go the other way. I could go this way, right here. I can go on this side, and I'll do the same thing. I can go over here, boom, 0, and, oops, I moved it a little bit. 0, 0, cross the 90 over here, 60, 120 still 120, no matter which side you use. So that's 120 degrees, and angle 4 is 120. So what's angle 1 plus angle 2? Well, 1 plus 2 is 180. 2 plus 3, also 180. 3 plus 4, 180. And 4 plus 1. So 4 plus 1, 60 plus 120 is 180. Okay, so share your results with others. Okay, I just shared it with you. Make a conjecture about pairs of angles that are opposite to each other. Okay, so these are opposite, right? Oops. These are opposite of each other, and these are opposite of each other. They're called vertical angles. You're going to learn that on the next page. So, all you have to see is their measures have a sum of 180. Wait, vertical? Wait. Oh, I'm sorry. I read the wrong one. Pairs of angles are congruent. They are the same. Remember, congruent means they have the same measure. So the ones opposite are congruent. They have the same measure right there. Zoom out a little bit. I'm having trouble keeping it on the screen. Okay, so make a conjecture. When two lines intersect to form 4 angles, what conjecture can you make about pairs of angles that are next to each other? Well, let's see, next to each other. This plus this, okay, that was 180. This was, their sum was 180. This sum was 180, and this sum was 180. So when you have that, their measures have a sum of 180 degrees. Okay. Next, we have types of angles. Vertical angles. They are opposite angles formed by intersecting lines, and they are congruent. So vertical angles are, for example, 1 and 3. These were vertical angles because these are intersecting lines and they're opposite of each other. And these are vertical angles right here as well. Okay, next, adjacent angles. They share a vertex and one side but do not overlap. So they share a vertex, one side. So they're next to each other. If you're adjacent to someone, you are next to someone. So angle 1 is adjacent to angle 2. Angle 2 is adjacent to angle 3. Angle 3 is adjacent to angle 4, and angle 4 is adjacent to angle 1. Complementary angles are 2 angles whose measures have a sum of 90 degrees. Okay, I'll show you that in a minute. And supplementary angles, 2 measures that have a sum of 180 degrees. So right here, we have these two angles 1 and 2 are supplementary because they have a sum of 180 degrees. All right, now name a pair of vertical angles. Okay, when you name angles, you start with, okay, this is an angle symbol. When I usually write angle symbols, I will do that, but I'm afraid you might think it's an L, so I do this as well. So that's my symbol for angle when I write it on a paper. So angle AFB. F is the vertex. That's the elbow of the angle. It doesn't matter. You can have BFA. BFA, that is the exact same name for the angle. As long as the vertex is in the middle, you can switch the other two. So BFA, BFA, that's this angle right here that we're talking about. So a pair of vertical angles, we have BFA and DFE, DFE. So these two are the vertical angles that they're talking about. Okay, they're opposite of each other and they are congruent. A pair of adjacent angles, AFB AFB, so I'll mark that right there, AFB, and BFD. BFD. So these right here, they share a vertex and one side right here. They are next to each other. So this is the vertex, and this is the side that they share. Okay, I'll erase that. Next, we have name a pair of supplementary angles. Okay, they're formed by intersecting lines that are supplementary. Okay, so AFB, AFB, AFB. Okay, so this angle again, and BFD, BFD, right there. And together, as you travel from here all the way to the other side right there, you've gone into this straight line, and every straight line is 180 degrees. Remember the protractor right here. As we travel, let's see, how is this easy? Yeah, here. See, as you travel from 0 all the way to the other side on a straight line, that's 180 degrees right there. Okay, so we have supplementary, and then 2 pairs of supplementary angles that include DFE. Okay, DFE. So I'll erase this, and you have DFE. So I need 2 pairs of that. So DFE and EFA, DFE and EFA. So what we're looking at is as you have this going to this. So EFA is the other angle that makes a supplementary, 2 supplementary angles, because you need to make 180 degrees. And then I'm thinking they're going to have, now there's one angle that gives you that. Now, if you have this, the other one's probably going to be DFB all the way here, because I want to travel from here all the way to the other side there. So DFB is exactly what they said right there. DFE and DFB. DFE and DFB. Okay. Find the measure of AFB. Okay, what is the measure of AFB? X, right there. Okay, well, I see that X, and that's 50 degrees. And this right here, this means right there that you have a 90-degree angle on that side. And how does that help you? Well, if this is 90 degrees right here, that means this side also is 90 degrees because we have a straight line. And we can assume that whenever we have a straight line, we have 180 degrees. So if that's 90 plus the other 90 is 180. So I can take X plus 50 equals 90. So X plus 50 is equal to the 90 degrees. So as you take this plus this, that equals the entire distance, which is 90 degrees. And then all I have to do is subtract 50. And I have X equals 40 degrees. I should have put degree symbols right there. So there you go. So, and they got X is 40, but they did it differently. They said AFB plus BFD. AFB plus BFD. AFB plus BFD. So they said, okay, we have this angle. Let me erase this here. They say that this angle plus the other angle is 180 degrees, which is true because you're going all the way over. So they said that plus that equals 180. So they say X plus 50, because that's 50, plus 90. And 50 plus 90 is 140. So X plus 140 is equal to the entire 180. And that's what's happening right here. X plus 140 equals the entire 180. And then they subtract 140 from both sides, like we solve equations, and you still get 40. So notice we did it 2 different ways. They did it this way. I did it this way. Both work equally well. Okay, so let's reflect here. Okay, analyze relationships. What is the relationship between angle AFB and BFC? Explain. So AFB, let's bring this over. AFB, boom. And BFC, BFC. So what is this relationship between these 2 angles right here? And when we're talking about what's the relationship, we're talking about, well, what kind of angles are they from this list here? And it looks like we're talking about complementary angles because their sum is 90. Remember, this whole thing is 90. So you have this angle plus this angle, and together that travels all the way to 90 degrees. So they are complementary angles. The sum of their measures is 90 degrees. Let's draw some conclusions on this. Are AFC and BFC adjacent angles? So AFC, and BFC. Okay, so let's see. We're talking about AFC, this, and BFC, this. So the question is this angle adjacent to this angle? Well, let's take a look at adjacent angles. They are pairs of angles that share a vertex and one side, but do not overlap. So they do share a vertex. Their vertex is F. And you can see it in the name right here. AFC and BFC, they share that vertex in the middle. But they do overlap. This part right here, they overlap. That's part of both angles right there. So, no, they are not adjacent. And adjacent, to me, they means next to. The adjacent angle to AFC would be maybe this one right here, CFD, or AFE. That would be adjacent to the angle, but these overlap. So, no, angle AFC and BFC share a vertex and one side. That one side is this side right here. Oops, this side right here. They share that side, but they overlap, and that blows it. Okay, so we have your turn questions. Name a pair of supplementary angles. Okay, I have FGA, so FGA, this angle here, and I need to go all the way 180 degrees. So AGC right here. And this allows me to travel from here all the way to there, 180 degrees. That's supplementary. Vertical angles. Well, we have several choices here, but I chose angle FGE, so this one, and it has to be BGC. So once I choose that, BGC, vertical, they're opposite of each other. And I look for the X's right there. That X right there, and then I look opposite. I could have chose many other options. I just picked that one. Name a pair of adjacent angles. Okay, FGD. FGD. So FGD, that's this angle here. And DGC. DGC. So there you go. Adjacent. They're next to each other. They share a vertex and a side right there. Complementary angles. Well, you got to look for that little right angle thing right there. That's where things start. And what we have is BGC. I'm going to erase this here. Now, this tells me 90 degrees, but there's no other angles in there, so I got to go somewhere else. That means this right here, that's also 90 degrees. And I kind of made that a weird square so I can accentuate that. And what I can use here is now inside this 90 degrees, there are two angles there. And those are the two I'm choosing here, BGC right there, and CGD, that right there. Those are complementary angles. Okay, find the measure of CGD. CGD. Okay, I got it. Check this out. There's a few ways I can go with this. First off, I see that. So, find the measure of CGD. So I need this right here. Now, what I can do is I can see that this is also 35 degrees because they are vertical angles. I can use the fact that this is 90 degrees right here. I knew that before. So this would just be 90 minus 35. And that's what I have here. That would be 55 degrees. So right there I have 55 degrees for that angle. And that, I believe, is what you need to know, that part. And we move on to angle pairs and two-step equations. Let me zoom out here. Sometimes solving an equation is only the first step in using an angle relationship to solve a problem. So find the measure of angle EHF. So we want EHF. What is the measure of that angle? Well, we need to identify that. They are supplementary angles because this angle plus this angle gets me from here all the way to the other side, makes that straight line. That straight line is 180 degrees. So they're supplementary. So we can write that EHF, so 2x plus 48 equals 180. That's what we got right here. So we got that, and we solve that, subtract, divide by 2, and you get 66. Find the measure of EHF. Well, they say that EHF is 2 times the value of x, and the value of x is 66. So I multiply 2 times 66, and that's 132. So the measure of angle EHF is 132 degrees. And so now we know that, and then we could check. So we could check this right here. The check here, 132 plus 48. So we are saying that this is 132 degrees. And to check, if I add this plus this, that should equal 180, and it does. Okay. In example B, part B here, identify or find the measure of ZXY. ZXY. So what is the measure of this? Well, together, this plus this is going to be, they're complementary angles, because that little square right there is telling me 90 degrees. So that plus that equals 90. 4x plus 7 plus the 35 degrees is equal to the full 90 degrees. So this plus this gets you all the way there. We'll solve this, subtract 42, and then divide by 4, and the value of x is 12. But that's not our answer, though. What we have to do is to find the value of ZXY. We have to put that 12 in for x. So 4 times 12 plus 7. That's the measure of this angle right here. And they have this right here. 4 times 12 plus 7, that equals 55. The measure of that angle is 55 degrees. So we have this here. Write and solve an equation for the measure of JML. JML. So this right here, we have two complementary angles. This angle plus this angle gets you all the way from here to the other side of this straight line. It's 180 degrees. So 3x plus 54 degrees equals 180 degrees. Solve for x. X equals 42. Okay. So, and find the measure of that. So that equals 42. Now, to find the measure of that angle, I would have to have 3 times 42, which is 126 degrees. So this is the measure of, so 3 times 42 is, because that's 3 times x, is the measure of that entire angle. So 126 plus 54 is the measure of that angle as well. God, you could probably do like a shortcut. You probably just do 180 minus 54, and that would tell you the size of that angle too, without going through the rest of the business. Okay, so Corey says that to find the measure of JML above, you can stop when you get to the solution of 3x equals 126. Explain why this works. You can stop at the solution step where you find the value of 3x because the measure of JML is equal to 3x. Yeah, JML is 3x right there. Done deal. All right, I believe that's all you got to know for this. Yep, guided practice up next.